Animation. Okay. ரெக்கார்டிங் அப்லோட் பண்ணிடுவேன் இன்னைக்கு. சரிங்களா? அது பார்த்து Hi guys, good evening. Just a minute. Okay. Okay, I'll share my screen. So yesterday we saw the configuration for this RTOS, right? So we configured the RTOS folder, and also we configure how to create a new project in STM, and how to change that project into an RTOS project. Okay. So that we saw yesterday, and today we are going to create a new task. Okay. And we will see what will happen with the task priority and all these things. So in order to create a task, again, I'll just go to this freeautos.org, and in that the API reference. Okay, so this is what and task creations API. Okay, so we'll be using this X task create and these parameters to create a task. Okay. Now, in order to use this Xtask create API, we need to include an header file called as task.h. Okay, so they are mentioned over here. For using this API, we need to include this header file in our program. Okay, so we are going to start writing the program. This is a program which we configured yesterday. So I'm just going to maximize this. Yeah. Okay. So now this is our generated code, right? So generated code, I have this main.h and all these things. Okay, so this is my user begin include file. Okay, so I'm going to include two files over here. Okay, so one is my freeatas.h. Okay, so that is one file. So for every FreeRTOS project, we need to include this file. That is a mandatory. Okay. After that, we need to give what are the things, what are the APIs we are going to use in that program. Okay, for example, if you are using an task, you need to include task.h. Timer means timer.h. Semaphore means smphr.h. Okay, and queue means queue.h. Okay, for that particular APIs, if you are going to use in the code, we need to include that particular header file. Okay, so here we are going to use a task. So I'm just giving task.h. Okay, so once you have included these two header files, just give build. So make sure these two are included properly in the project. Okay, if it is not included properly, it will show some error. Okay. Okay, so I have included these two header files in my code, and I'm going to start writing my code. Okay, so first one, I'll just scroll down this user begin um, 0. Okay. Now I'm going to create two new task. Okay. Two new task. In that, I'm going to give all these parameters as like what I just a minute, what I given yesterday. These parameters. Okay, so for creating a task, we'll be giving the function name, the string name, and the size of the stack. Okay, if there is any argument, we'll be giving that. And this one is for the priority. And if there is any handler, I'll be giving it. Okay, so we will be creating two different things like this. Okay, and based on that, we are going to create a task. Okay, just a minute. Just a minute, guys. I'll be back. Okay, sorry. Okay, so we are going to create two different tasks. Okay, so for that we'll be using this xtask create file, right? Okay, so I'm just directly going to this main function. Inside this main function, there is after this GPU initialization and all these things, we have an user code begin to. Okay, on the first class itself, I think we saw this one. Your polling method or your device driver development program will be giving inside a single while of one. Okay, whereas the RTOS will be having an each and every individual task is having a different while of one. Okay, so we won't use this while of one in our RTOS program. Okay, we won't use any of this. This is your no polling method. Okay, so will not write any program inside this while of one. Okay, so here on top of this while of one, we have a user code begin to. Here I'm going to create two different tasks. Okay, so what is the API to create a task? It is an X task create, right? So I'm just going to give X task create. Okay, if I give control space as like our device driver program, it will just give all these suggestions. Okay, first one is the function name. Okay, so I'm just giving something like an task number one. Okay, that is my function name. And the next one is PC name. PC name is you can give something in the double quotes. That is your wish. I'm just giving something like an task one. Okay. You can give any name. You can give your name or a first program or a first task, something like that. I'll just give something like a first task. Okay. You can give anything inside the double quote. That is for our understanding. Whenever we are debugging the code, we need to know which task is created. Okay. For that, we'll be giving that in the double quotes. And second one, the third one is the stack depth. You can give any stack depth in the word length. Okay, I'm just giving 200 word length over here. So that means 200 into 32 bits. Okay, that is not something, but we'll be having 6400 bits. Okay, or 6.4 KB. Okay, 6000, right? Yeah, 6.4 KB. That we'll be using for this task. And parameter, as of now, I'm not going to use any parameter. Okay, I'm just giving null. And priority, I'm just giving 3. Okay, and handler also, I'm not going to use anything. Okay, I'm just giving null. For our first program, I'm just giving a function name, a name for my task, and the stack size. What is the stack size and what is the priority? Okay, and I'm just copying the same thing again. Let's create this as a second task. And here I'm just giving something like a second task. Okay. Here I'm giving the priority of this task as 2. Okay. So in my user code begin to, I have created two different tasks. One is named as task number 1 and second one is named as task number 2. Okay. After this, it is a very important thing we need to do. As we already discussed in the theory part, your RTOS is working based on the scheduler. Okay, so we need to start the scheduler after creating all the tasks in order to switch between these tasks, or the scheduler is the one who is going to put this task from the ready state to running state. Okay, so after creating the task, we need to start the scheduler. So starting scheduler, the API for that is vtask start scheduler. Okay, so that's it. So this is for creating a task. I'm creating two tasks. One is having a 3 as a priority and this as a 2 priority. And then I'm starting the scheduler. Okay. That's it for creating a task. Okay. Now we need to give what this task 1 will do and what this task 2 will do. Okay. That we need to write a definition. Okay. So as I already said, I'm not going to use this while of 1. That is my user code begin 3. This is only for the device driver module. Okay, driver development will be writing everything inside a infinite loop. Okay, here I'm not going to use that. So I'll just scroll down. There is something called as user code begin 4 over here. Okay, so I'm going to write the definition for those two tasks. Okay, so first task is void the same name, task number 1. I think I have given T capital. Yeah, the same thing. Okay, task number 1. Here I'm just giving it. Okay, inside this, even though you are passing an argument or giving null, you have to use an void pointer over here. Okay. This PTR, you can give any name, that is a variable name pointer, but it has to be void pointer. Okay. Even though you are given it as a null, that means we are not passing any arguments here. Okay. Even though we have to give something like a void pointer. Okay. Inside this task will have its own infinite loop. Okay. So this is, I'm just writing something like an printf. This is task number 1. Okay. So I'm just giving /r/n for printing in the new line. Okay. So this is my task number 1. So I have created an task 1 as a function. Inside this, I'm getting an argument as a void pointer. And inside a infinite loop, I'm just giving an task number 1, this one. Okay, I'm just going to copy this same thing and I'll paste it here. If I'm just giving it as a task 2 and I'm going to print it as a task number 2. That's it. Okay, so I have created 2 different tasks. One is for this task number 1, which has a priority of 3, and the next one is task number 2, okay, which has a priority of 2. Okay, now that is a code. Okay, we have created 2 different tasks and we have given what this task has to do, right? I'm just copying this. Okay, if I build this, it will show some error. Okay, so the error is nothing but implicit declaration of this function. Sorry, this is warning. Where is error? Yeah, this one. Okay. So it says that task 2 is undeclared, task 1 is undeclared. Okay, that means we have used this function, but this function is not declared on the top. Okay, so for that, what are the functions you are using here in the program? You just need to declare that on the top. So where is this private function prototype? Yeah, here you can see user code begin private function prototype. Okay, PFP. We need to declare these 2 functions over here, task 1 and task 2. Okay, that's it. So a simple code, we have created 2 different tasks and I have given the stack size for that. I have given the priority for that, and each and every task, what it is going to do, I have given it. Okay, so now I'm going to build the code. Okay, I'm getting one error. This is for the printf statement. Okay, so I need to give an hash include stdio.h. Okay, so that is for using the printf statement. Okay, so now we can see it is 0 errors and 0 warning. Okay, now we are going to download this code to my board as like what we did in the uh, device driver. Okay, but here we need to do a few more things because we are going to use an uh, the serial wire viewer, right? That is ITM code which we have copied yesterday. We are going to use that, so we need to enable that. Okay, I connected my board. Okay, so this is my project. Right click, debug as STM32 C++ application. Okay. Usually what we will do in our device driver, we'll just simply click OK, right? But here what we need to do, we need to go to this debugger tab. Okay, here. And just scroll down and enable this serial wire viewer, this particular one. Okay, enable this and make sure your clock frequency matches with your clock frequency on the IOC file. Okay, and in IOC, I'm just giving it as an 8 megahertz only. So it is 8 megahertz. I'm just enabling the serial wire viewer. That's it. The port number is constant. Okay, no need to change anything. Only enable this serial wire viewer in the debugger tab. That's it. Okay. After that, click OK. Now your okay, it is asking for me to update. Okay, just a minute. This is for my board. Okay, my firmware is upgrading over here. So right click, debug as STM C++ application. Okay, so once you give this debugger that enabling serial wire viewer, it will ask, do you want to switch to the uh, debugging mode? Okay, I'm just clicking yes, switch. Okay, so now we are inside the debugging mode. Okay, now we will usually see the output in the console by clicking this console and all these things, right? Here we need to do something different. Okay, so just go to window, and there is something called as in show view. Okay, go to that, and there is an SWV, that is an serial wire viewer. Okay, go to the serial wire viewer and click this serial wire viewer ITM data console. Okay, so once again I'll tell, window, show view, serial wire viewer, and serial wire viewer ITL data console. Okay, just click that. Now this serial wire viewer IT data console will open. Okay, we are going to see our output, that is your printf statement output over here. This is only for the printf statement I'm saying. Okay. Okay. So now once this is open, click this first icon. Okay, this spanner and this one icon. Okay, screw icon configuration. Just click it and it will open a configuration tab. Okay, in that enable this bit number 0. Okay, just click this one, this bit number 0, nothing else. Only click this bit number 0 and then click OK. Now your port 0 is open. Okay, configure this one and click OK. This port 0 will open. Okay, and next you have to click this red color icon. This is nothing like your record button. Okay, start trace. Whatever the output coming, it will trace and it will print it over here. Okay, that is what the start trace is. Click it to enable, and then now click this resume. You will get the output. Okay, now you can see I have two different tasks, task 1 and task 2. Okay, but I'm getting only this task 1 as an output. Why?
So it has a high priority.
Yeah, so since my task 1 has an high priority, even though task 1, task 2 both are in the ready state, your scheduler will always pick task number 1 because it has an high priority. Okay, I'll just do one more thing. I'm just going to terminate this session. Now I'm just giving this task number 2 as 4. Okay, that has an high priority. I'm building this code. I'm debugging it again. Okay, switch the same ITM data console. It is already enabled. So I'm just clicking resume. Now you can see this is task number 2 that is printing. Okay, because task number 2 has an highest priority. Okay, so depends on the priority of your task. No matter how many tasks you have created, the high priority task will be keep on running. Okay, so that is what the job of a scheduler, and that's what an RTOS is also. Okay, so this
Sir, one
is yeah.
can we give both as the same priority?
Yeah, that I will show as the next example. Okay, this is the first code, so I'm just giving the high priority task will run. Okay, we'll see one by one, and we will see how to switch to the low priority task also. Okay,
Oh, okay, sir. Okay.
yeah. Okay, so copy this code. First give these header files. Let me know once you finish it. I will just scroll down.
Can you scroll down, sir? Include it.
Um, don't type this one entirely. This one. Okay. Just type X task and then give control space. It will finish for you. Okay. Because it is a case sensitive. Just if you miss something like an C as a small or T as a small, it will throw an error.
Sir, done.
Okay. Others. This is done, right? Can I scroll down?
Yes.
Okay. And this is on user code begin for.
So,
Yes, Naveen.
sir, is actually usual but usual the usual begin three with us usual begin three day on program like I the
ஆமா.
support four like use.
த்ரீல வந்து நம்மளோட எஸ்டிஎம் ஒயில் ஆஃப் ஒன் இருக்கும்.
Okay, sir.
ஓகேவா?
Okay, sir.
அந்த ஒயில் ஆஃப் ஒன் வந்து அந்த இன்ஃபினிட் லூப் போலிங் மெத்தட்காக. அதாவது நார்மலாக நம்ம கண்டினியூஸாக ஒரு விஷயம் நடந்துகிட்டே இருக்கணும். இப்போ ஒரு எல்இடி மில்கிங்னா எல்இடி மில்கிங் திருப்பி திருப்பி நடந்துகிட்டே இருக்கணும் அப்படின்றதுக்காக அந்த ஒயில் ஆஃப் ஒன் யூஸ் பண்ணுவோம். இது வந்து ப்ரியாரிட்டி பேஸ்ட்.
Okay,
ஓகேவா?
okay.
அதனால இது நம்ம தனியாக தான் கொடுத்து எந்த ப்ரியாரிட்டியோ அதை மட்டும் கால் பண்ணி அதை மட்டும் ரன் பண்ணுவோம்.
Okay, okay.
ஓகே.
Okay.
Done, sir.
Okay, now so right click the project, go to debug as STM32 C++ application. Okay, so once you click, go to debugger and enable this serial wire viewer, this one. And then click debug.
Sir, once
So,
again, right click and
right click, debug as STM32 C++ application.
yeah. After that, I'm getting debugger. I'm not
Debugger,
showing interface. Yeah,
just
I'm showing
scroll down.
interface as
Oh, not that one. Just scroll down. You will find something called as a serial wire viewer.
okay.
Okay, enable that one.
And then, sir,
Yeah. Are you inside this one? This debugging mode. Click switch and then open this debugging mode. Is it done?
yes, sir. Now,
Okay. So now click window on top. Go to show view serial wire viewer, SWV. Okay. In that, click SWV ITM data console. Window, show view, SWV, SWV ITM data console.
okay.
Okay. So you will get something like this, a tab. Okay. Now in this, click this configuration icon. This one on the right side, first icon. Click this and enable port 0. And click OK. So once you're done, you'll get something like in port 0 over here.
Done.
Done. Okay. After that, click this start trace, this red color icon. Click it once and then click resume. You will get an output.
Configuration icon.
Configuration icon click பண்ணிட்டு port 0 enable பண்ணும்.
இல்ல சார் கான்ஃபிகரேஷன் ஐகான் எங்க இருக்கு தெரியல.
இங்க ரைட் சைடுல ஃபர்ஸ்ட் ஐகான்.
ஆ
ஓகே. அதை கிளிக் பண்ணீங்கன்னா port 0.
ஃபர்ஸ்ட் ஓகே சார்.
ஓகே. நெக்ஸ்ட் ஸ்டார்ட் ட்ரேஸ் கொடுத்துட்டு ரெஸ்யூம் கொடுத்தீங்கன்னா யூ வில் கெட் நோ. இங்க ரெட் கலர் ஐகான் இருக்கு இல்லையா பக்கத்துலேயே, கான்ஃபிகரேஷன் பக்கத்துல, அதை ஒரு தடவை கிளிக் பண்ணிட்டு அப்புறம் ரெஸ்யூம், மேலே ரெஸ்யூம் ஐகான் இருக்கும் இந்த இடத்துல செகண்ட் ஐகான், அதை கிளிக் பண்ணீங்கன்னா உங்களுக்கு அவுட்புட் வரும். ஆர் யூ கெட்டிங் அவுட்புட் முகமது?
Yes, sir. I'm getting output.
Okay. Arvind, what about you?
Yes sir, getting.
Okay, you are using a different board, right? So that's what I'm asking. It's okay.
Yes.
Yeah. Okay, fine. Yeah. So
I'm getting trace buffer is full.
Okay. So once it is completely running, we are actually, what is happening, right? This is not an real-time data. Okay. Since we are using this ITM, your data will be transferred to ITM buffer. From this ITM buffer, we are taking it and printing in the printf statement. Okay. That is why this ITM code which you have copied and paste. Okay. So if you keep on running, that buffer will get full. Okay. So you have to stop it again and then you have to run it. You have to get an output. Okay. Okay. So I hope everyone got an output. Now, so as like, I don't know who asked it. I think Mohammed or Arvind. Okay. What happens if both this task has a same priority? Okay. So that is, I'm just giving both this task as a 3 and 3. Okay. Now, first, your scheduler will pick any one of the task. Mostly it will pick task number 2. Since we are using a stack here, stack means it is an last in first out. Okay, so since this task is created last, it will execute first. Okay, sometimes it will execute the first task also. It depends on your scheduler. Mostly it will pick task number 2, but anyhow, it both has the same priority only, right? Okay, first it will pick task number 2. It will start executing it. In the next tick, what will happen? It will check this. First class we saw that, oh, sorry, just a minute, I'm getting a call. Yeah, sorry. So I'll just open this one note. Yeah. So first class we saw this task states, right? Okay. So now what is happening is task 1 and task 2 both are same priorities. Okay. Now your scheduler will pick one task and it will put in the running state. Okay. In the next tick, what will happen? It will check the ready state. If there is any task which has an high priority or same priority, then the running task. Okay. So we have one more task, right? So now what will happen? This task, what are the tasks currently running? That will be moved to the block state, and this task will put in the running. Okay. Again, from block state, it will go to ready. And in ready, it will just move. So this thing keep on running. Okay. So your task 1, task 2, task 1, task 2 will keep on running since it has the same priority. Okay. So that's what we are going to see right now. But there is one more catch there. Okay. I'll explain what it is. So I'm just building the code. I just changed this as a 3 and 3. That's it. Okay. So same debug and switch. So in ITM data console, same thing, configuration and trace is enabled. So I'm just giving a resume. Yeah. Okay. Now I'll just click the suspend to visualize this one. Okay. Now we can see this is my output. Okay. I'll just go to top. Okay. I'll do one thing. I'll just copy a few tasks and I'll run it in the notepad so that we can able to visualize it better. Okay. This is my output. Okay. Initially, you can see this is task 2 is running for 2 times. And then this is task 1 is running for 2 times. Okay. And only TH is printing. And then task number 2 is printing for 2 times. Okay. And then here we have T, right? And HIS is task 2 that is printing over here. Okay. And similarly, this is task 1 And here we can see this is printing. After that it is stopped, and then this is task 1, this is task 2, this, and here we have this is right, and this task 2 is printing over here. Okay, so this is what I call the first class. We have something called as a preemption method, right? So preemption method, even before finishing execution, if there is any high priority task comes, it will stop wherever it is executing. It will go and attend that high priority task, and it will come back to this previous task, and it will start executing from there. Okay, this is an example for a preemption. So what is happening is it is printing this is okay. After that it got preempted, so it moves to the another task and it is printing over here. Okay, and similarly the next task is printing over here, and this task is printing as this, and after that it is preempted. So here it is left from this is task 2. Okay, that is printing over here. Okay, and similarly here it is stopped with this, right? And you can see over here this is task 1, that is printing over here. Okay, and similarly here you can see this is task, okay, TAS. Okay, and this K2 is printing over here. Okay, this is what called as a preemption. Okay, so your kernel will not wait for the task to be completely executed. Okay, so whenever there is an high priority task comes, whatever it is executing, it will stop there itself, and it will go attend the new task. It will execute it, and then it will come back to the task where it is stopped. Okay, this is what called as a preemption method. Okay, so this preemption method will happen when there is an same priority task is given, or whenever we are running a low priority task and suddenly high priority task comes, means it will just preempt it. Okay, so that is then example for preemption. Clear?
Yes, sir.
Okay, now I'm just going to give the same thing like 3 and 2. Okay, now in my task number 2, I'm just going to print this is task 2, and also I'm going to blink my inbuilt LED. Okay, let's assume like that. I'm going to blink my inbuilt LED in task number 2. Okay, so we know how to configure an LED, right? We saw that in the device driver program itself. So I'm just going to this IOC file. Yes. Okay, so my inbuilt LED is connected to PA5. Okay, so I'm just going to click this PA5 and make it as a GPIO output. Okay, so all these things we saw in the device driver itself, so I'm just not explaining it much. I'm just clicking this PFI and make it as a GPIO output. So Control S and generate the code. So my code is generated for this GPIO. You can see over here, this is my GPIO generated code. Okay, now in this task number 2, since it has an high priority task, I'm going to toggle my LED. Okay, so what is the API for toggling the LED? What is the API for toggling the LED? HAL API. What happened? You people forgot device driver.
HAL GPIO.
Okay, so it's al underscore GPIO, okay, underscore toggle. Okay, it will ask two parameters. One is which port and which pin. So port is A and pin number is 5. Okay. Now, in order to visualize this, okay, if I build this code and run it, what will happen is I will not get this blink because I'll show you what happens. Switch. Okay. Same ITM data console. I'm just clicking it as resume. This is task 2 is printing, but my LED is not blinking. It is constantly turned on. Okay, I'll show you in the video. Mm, Teams. Teams. Yeah. Mm, Okay, you can see my LED is constantly turned on, but I have given toggled LED, right? Okay, here I'm giving toggle. Why I can't able to visualize this toggle is because there is no delay function over here. Okay, I need to give the delay function in order to visualize the toggle. Okay, I'll show you this delay function. So what is the delay API?
HAL underscore delay.
Okay, so I'm just giving something like, let's say 500 milliseconds. Okay, I'll building it, debug. Switch ITM data console. I'm just clicking a resume. Okay, now I'll get this. Sorry. Now I will get this LED blinking for 500 milliseconds. Okay, you can see it over here. My LED, inbuilt LED is blinking for 500 milliseconds. But the problem here is my task also running for 500 milliseconds. Okay, each and every task is executing for 500 milliseconds. Okay, what is the problem in that? Okay, that is a question. Because the problem here is we are working with a real-time operating system, right? Okay, what is mean by real-time operating system? Your microcontroller or your device has to strictly obey the time limit. Okay, but what we are giving here is we are asking your CPU to wait for 500 milliseconds in line number 190. Okay, during that 500 milliseconds, if there is any high priority task comes, your CPU will not pick it up because we are waiting in line number 190, right? Okay, so the whole purpose of this RTOS is not used when we give this al underscore delay. Okay, so this delay function should not used in the RTOS. So that is the first row. Okay, delay should not use in not only delay, your delay function, your for loop, okay, your while loop, it should not be used in the free RTOS because for loop again it will take some time uh, to come out of that loop, right? For example, if you give something like an for I int I equal to 0 to I less than 1000 I plus plus, okay, from 0 to 1000 you are stucking inside that for loop, correct? So you should not use a for loop, you should not use a while loop, and you should not use a delay function in the free RTOS. Okay, that is the rule number one. There should not be any delay given. Okay, now there comes another question. I want to visualize this LED blink, right? Without delay, how can I able to visualize it? If I remove this delay, it is toggling, but I couldn't able to visualize this toggle because it is happening so fast, right? So I need to use a delay in order to visualize this LED, but delay should not used in the free RTOS. Okay, then what should I do? That is the question. You can see the output. The output is it is printing task number 2. Okay, it is constantly printing task number 2 because task number 2 has an high priority. Correct? Okay. Now I want to use the delay function but it should not affect my CPU, right? So for that, we have a specific delay function that is available for the FreeRTOS. That is vtask delay. Okay, instead of using an HAL delay, we'll be using something called as an vtask delay. Okay, and it is asked what is the number of ticks to wait or number of ticks to delay. Okay, I'm just giving the same 500 ticks now. Okay, now you can see the changes in the output. Here you can see is everything is task number 2, right? What I have given is my priority 3 and 2. That is my second task as a 3 priority and my first task as a 2 priority. Okay, I'm just terminating this. I'm building the code and I'm just giving the debug. Switch data console. Okay, I'm just clicking the resume. Now you can see I'm getting the same this blink one. Okay, it is blinking, right? Okay, now what is the output I'm getting? I'll just pass this one. Okay, what is the output I'm getting? Task number 1, right? Okay, but my task number 2 has an highest priority. Okay, then how this task number 1 is executing? That is the question. Okay, I'll just oh, it's clear now. Just a minute, I'll just copy this and I'll put it in the notepad entirely. Okay, we will find task number 2. It's not okay, it's cleared, I think so. Yeah, you can see it over here. This is task 2. Okay, and after that task number 1. So what is happening with the vtask delay is we need a delay, but it should not affect the CPU, right? So what happens? Your RTOS itself is having a delay function. Okay, now this means I am telling my compiler or my scheduler I need a 500 millisecond delay. Okay, don't pick me for 500 milliseconds. So this task 2 will be available in the blocked state for 500 milliseconds. Okay, and what is the only task available in the ready state? That is task number 1. Okay, so for this 500 millisecond, your task number 2 will be in the running state, even though it has a low priority. Okay, after 500 milliseconds, again this task number 2 will come from block state to the ready state, and this task number 2 will be in the running. Again 500 milliseconds, it will be in the block state. Okay, so this is how you can able to switch from the high priority task to low priority task by using this delay function. Okay, if you want to visualize it further, I'll just give the same vtask delay for both this task. Okay, now you can see the change in output. Okay, now I'm just giving this resume. Yeah, you can see task number 1, task number 2, 1, 2, 1, 2, 1, 2, 1, 2. That will be keep on printing because both task is having a 500 millisecond delay. That means first task number 2 will execute. It will go to the block state for 500 milliseconds, and task number 2 will execute, and again it will go to block state for 500 milliseconds. Again task number 1 500 milliseconds block, task 2 500 milliseconds block. Okay, it will be keep on executing, right? So this is how your blocked state will get work. If you are given the
Sir,
vtask delay, yeah.
delay means it will put in the task in the block, right?
Yeah, it will be in the block state. Yeah. What's the question?
Yeah, that's it.
Okay, okay. So what is happening is your ready state is free now, right? Okay, in our previous all delay, what happens? We are stuck in the running state itself. Okay, for the 500 milliseconds. So if any high priority task comes and waits in the ready state, we couldn't be able to pick for that 500 milliseconds. Now we are inside the block state. So ready state is free. If any high priority task comes, your scheduler can pick that and put in the running state. That is the difference between HAL delay and VTAS delay. Okay, your VTAS delay will not disturb the CPU for preemption, whereas your HAL delay will make you wait in the running state, so the preemption will not happen if an high priority task comes. That is the difference. Okay, I'll give you and one more thing. I'm just giving it as 1,000 ticks over here for task number 2. And task number 1, I am giving a 500 milliseconds delay. Okay, now you can see I'm just saving it and building. Okay, so your task number 2 as 1,000 and task number 1 as an 500. Okay, now if I run this, you can see I'll just pause this. I will copy and paste it in the notepad. Okay, I'll just delete this one. Yeah. You can see now your task number 1 will execute for 2 times and your task number 2 will execute for once, because your task number 2 is having an 1,000 milliseconds delay. So it will wait for 1,000 milliseconds. During that time, it will execute for 2 times because it has a 500 milliseconds delay, right? So it will execute for 2 times. So this will execute once, this will execute 2. Again, this will execute 1, this will execute 2. Okay. So if there is any new priority comes, like in task number 3, it can attend and go to task number 3 also, because you are already stated free in the VTAS delay. So in your pre-ATAS, you should not use AL delay in any cases. Okay, for even though your application demands, you should not use the AL delay. Okay, you should only use the VTAS delay so that your CPU can attend the high priority task. Clear? What is the difference between VTAS delay and AL delay?
Yes.
Yes. Okay, so now write this one. Only change this one and start writing. So in order to use this toggle pin, you have to enable it in the IOC file. Okay, don't forget to enable it in the IOC file and then generate the code and then use this toggle pin. Okay.
Sure.
Yeah.
Sir, actually, output வரல சார் ஃபர்ஸ்ட் பண்ணாங்க அது
First output வரலையா?
நம்ம ட்ரை பண்ணிட்டு வந்துருக்கலாம்.
சரி, ஓகே. இது காப்பி பண்ணி முடிச்சிட்டோம். அதுக்கப்புறம் நீங்க ஸ்க்ரீன் ஷேர் பண்ணி காமிங்க. என்ன அவுட்புட் செக் பண்ணி.
ஓகே சார்.
ஓகே. Let me know once you finish and getting an output. Okay.
So I'm getting output.
Okay, Mohammed.
So while loop also we should not use, right?
Yeah, while loop.
Okay.
Yes. Any looping statement will work as an delay function, right? Same thing. Your delay function inside this, you will be having a looping statement only.
Inside while loop or this, what is there in line number 188? This while loop we should not use, or like inside that while we should
No,
not
no,
use
no,
while.
not this one. This is your infinite loop. This is fine. Okay. I'm telling you should not use something like for
Okay, okay.
this one. Okay. If you give something
Okay.
like this, until this condition fails, it will not come out of this loop, right?
Mhm.
Okay. That is a problem.
Okay. Okay.
Yeah. And we got output.
Yes, sir.
Okay. Naveen, can you share the screen? Actually, you are having problem with the connection of the board. Okay, this is fine. Build the code. Okay. Right click, debug as. Okay, don't click that. Click debug configuration. Click debugger. Okay, you are enabling. Is it 16 megahertz? Which 303 you are using? 303 16 megahertz. Okay, okay. Click debug. Switch. Okay, click that configuration. Yeah. Okay, port 0 is enabled. Okay, click OK. Click that start trace. Yeah. Okay, now click resume. Uh, Getting okay. Can you just click pass? That resume, after that resume, there's a pass button. Okay, click yes. Close this one. Okay, can I just scroll up a little bit, Arbo? Scroll up, scroll up. No, not yet in the program. Scroll up. Okay, you are inside an delete function. Okay, terminate the session. Click terminate. Okay, open the core folder on the left side core folder. src syscall.c. Open that. Double click syscall. Yeah. Okay, can you just scroll up? Up. Okay. Okay, scroll down a little. Scroll down, 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 down. Okay, wait. So here you are giving ITM underscore sin care of this plus plus. Okay. This looks fine. Actually, your board is shut down. Okay, can you just scroll? Yeah, that one. Can you scroll up? No, the console. Yeah, scroll up. Scroll up, up. Scroll up. Okay. Actually, your program is not properly downloaded to the board. Okay. So that is the issue. Can I check your board? Do one thing. Just take a photo of your board from the top angle and send it to my WhatsApp. Okay. Your board, the board which you're having, a clear picture of the board. I want to see these jumper pins where it is connected. I want to see it. Okay, take a picture and send it. We will rectify it later after this class. Okay. Send the picture now. I'll just check it and let you know. Because your GDB is shutting down whenever you are trying to have a connection with the board. So we will check what it is. Mm. Okay, 3, 4, 5, 6. Your jumper pins are correct. Then what is the issue? கேட்கல நவீன், ரொம்ப ஸ்லோவா கேக்குது உங்க வாய்ஸ்.
ஆல்ரெடி பிளிங்க் ப்ரோக்ராம் அதெல்லாம் ட்ரை பண்ணி பார்த்தேன் சார்.
அதெல்லாம் வருதா?
அதெல்லாம்
இது
work
மட்டும்
ஆச்சு.
வரல.
ஆமா சார், புஷ் பட்டன் எல்லாமே ஒர்க் பண்ணி பார்த்தேன், எல்லாமே ஒர்க் ஆச்சு சார்.
சரி,
ஐஓசில
நெக்ஸ்ட் ப்ராஜெக்ட்
ஏதாச்சும் ப்ராப்ளம்?
மேபி ஏதாச்சும் இருக்கும்னு நினைக்கிறேன். சரி, நெக்ஸ்ட் ப்ராஜெக்ட் கிரியேட் பண்றேன். அந்த ஸ்டெப் மட்டும் கரெக்டா ஃபாலோ பண்ணுங்க. We will check
Okay.
that. அப்பயும் அதே error வருதுன்னு பார்ப்போம்.
ஓகே
Okay.
ஓகே சார்.
Yeah, okay. So I hope everyone got output for this one. Okay. So this is the preemption method. Okay, that means your scheduler can decide which task has to run and which task it has to stop executing. All these things can be decided by your scheduler itself. Okay. And there is one more method which is called as a cooperative method. Okay, preemption method can be done by your scheduler, and there is a cooperation method. Cooperation method is manual switching between tasks by the user. Okay. Sorry. We can switch from one task to another task by giving some APIs. There are some APIs available as like this vtask delay and some more APIs. Okay, we can able to switch between one task to another task. Okay, that we are going to see right now. So I'm going to create a new project. So we need to follow the same steps again, like what we did yesterday. I'll create a file, new STM32 project.
Sir, you are not sharing this.
Green visible.
Oh no, not sharing the screen now. Sorry. Okay. Now,
Okay sir.
okay. So I'm file, new STM32 project. I'm selecting this MCU MPU. In that I'm selecting the board which I'm using. Here I'm clicking. Sorry, I'm typing something like an cooperative underscore task. Okay. So it is opening an IOC file for me. As of now, IOC file is not important, right? So I'm just directly going to this folder wherever I have created this free RTOS kernel configuration, all these things. Okay, I'm just copying this folder and okay, I'll just close this one, my previous project. Okay, so inside this cooperative method, I'm just pasting this free RTOS kernel folder. Okay, this is step number 1. Okay, I'll just close this also. Okay, so I've copied and pasted this free RTOS kernel folder. So step number 2, right click, properties, C++ build. I need to remove this tick mark. Okay, in order to include this folder. Apply and close. Step number 2 done. Step number 1, copy and paste. Step number 2, include that folder for building. Okay. Step number 3, right click this project, go to properties, open this C++ build, settings. We have an MCU MPU compiler. Okay, in that include path. So add workspace. I'm just opening this cooperative task, free RTOS, include portable GCC, everything. Okay, in that I'm selecting memory management, ARM CM4F, and include these 3 folders. Okay, and I'm checking here, these 3 is listed. Okay, include ARM CM4 and memory management. Apply and close. Done. Okay, so once I click build, yeah, it will show 4 errors for this multiple declaration. Okay, multiple definition of these 3 things. So we know what to do with this, right? So step number 1, 2, 3, 4. Step number 4 is go to IOC. Okay, so here system core, same thing, RCC, make this bypass crystal ceramic enabled. And in NVIC, I'm just going to make this as a 4-bit preemption. And in code generation, I'm just going to remove the time base, pendable request, and system service. These three, I'm just telling not to generate the code. Okay. And in sys, I'm just going to make the system tick as timer number 3. Okay. So these three things I need to do. Okay. So in order to make my LED for any users, I'm just making this PFI as an GPIO output now itself. That's it. Okay, this is for application oriented. These things you need to do, like your RCC, sys, and NVIC. Okay, so once you've done all these things, just click Ctrl S and generate the code, or give Alt plus K to generate the code. Okay, once this code is generated, now click Build. You should get 0 errors and 0 warnings. Okay, done. So this is common for all the FreeRTOS code. Okay, if you are using an printf statement in the code, then you need to make sure to do one more thing, that is you need to copy and paste this ITM sendcar file. Okay, so I'm just copying this, Ctrl A, Ctrl C, and I'm just opening my core src syscall.c. Here after this header file, I'm just pasting here. Okay, now I'm copying this ITM sendcar, scrolling down. Okay, in this write function, instead of this IO put char, I'm just replacing it with ITM sendcar. That's it. So after this, build and make sure 0 errors and 0 warnings. That's it. So this is the configuration part that is done. Okay, so now we are going to use the cooperative method. Okay, for cooperative method, I'm just going to use the same hash include freeRTOS.h and hash include task.h. I'm going to use a task here, and I'm going to use a printf statement. So stdio.h. Okay, so these three header files I have added: FreeRTOS, task, and stdio.h. So I'm building the code. So these three are added to my code. Okay, there is 0 errors and warning. Okay, now I'm going to create a same two task again. Yeah, in user code 2. Okay, I'm just going to create a task like x task create. Okay, so here I'm giving something like I'll give a different name. I'll give something like in function 1, and this is task number 1, and stack depth I'm giving 200. This is null, and this is priority 3, and this is again null. Okay, now next thing, I'm just going to copy the same with I'm just giving it as a function 2, and this is task number 2. Okay, here it is, v task start scheduling. That's it. So I have created two different tasks with the same priority, and I have started the scheduler. Done. Okay, now I need to write a function for these two things. Okay, so same simple function, like I'm just going to print it with an LED blinking. That's it. Okay. Okay, what we will do is I'm just going to create an void function number 1 with void pointer. Okay, here while of 1, inside this infinite loop, I'm just going to what I will do. Okay, let's see. I'm just going to put a printf statement with this is up, or I'll just simply put LED on in task 1. Okay, this is /r/n. I'm just going to make this LED on in function number 1. Okay, so for that I need to use an al API, right? So al underscore GPIO underscore write pin. Okay, this is GPIO and this is pin number 5, and pin state I'm just giving it as a set. That's it. Okay, these things we already saw in our previous module itself, so I'm just moving it fast. Okay, if you're not understanding it, just ask me, I will explain this one. So this is function number 2. Here I'm just giving LED off in task number 2. Okay, this is reset. So task number 1 is going to turn on your LED and task number 2 is going to turn off your LED. Okay, I'm building the code. Okay, so the error is I didn't define this function prototype over there. So I'm just giving this function prototype. This is function 1, this is function 2. Okay, so build. Yeah, so this is 0 errors and 0 warnings. This is same code like what we did in our previous this first project one. Same thing I have done. Okay, instead of toggle pin, I'm just making one function to turn on, one function to turn off. Okay, so why I have given like that? Because both my priorities are same priority. Okay, so it will keep on switching, right? So I'm just giving it something like that. So I'll build it and I'll create this debug as STM32C C++ application. In debugger, I'm just going to make this serial wire viewer enable and okay, that's it. Switch. Okay, yeah, done. Now serial wire viewer, configure port 0 and okay. Here I'm just starting the trace and click resume. You can see LED on, LED off, LED on, LED off is keep on printing. Okay, this is preemption method, right? So what we did in that previous thing, same thing, LED off, LED on, LED off on, that is keep on printing. I couldn't be able to visualize the LED blinking because it will happen very fast. Okay, I couldn't be able to visualize it. This is preemption method. You can see the output. I'll just copy and paste this output in the notepad for you people. I'll just close this one. Yeah. So this is preemption methods output. You can see over here. Okay, it is like very clumsy something. Okay, so this is what happened in the preemption. Now we need to use this in the cooperation method or cooperative method. Okay, how to do this? I'll terminate this one. Okay, in order to make this to work in the cooperative method, go to this FreeRTOS kernel folder. Okay, open this one. There is an include folder. Open this include folder and there you will find something called as FreeRTOS config.h. Okay, there is an header file. Open this header file. Okay, this file I have sent to you in your WhatsApp, right? That same file. Okay, now we are going to explore what it is given inside this file. So whatever the configuration you are going to do for your FreeRTOS, you need to give this inside this file. This file is very important for your FreeRTOS. Okay, all the configuration has to be done inside this file only, your FreeRTOS one. Okay. Yes. So if you scroll down, there will be a multiple as defined macros over here. Okay. The first macro is config use preemption. If you are going to use a preemption method, you need to make it as 1 or sorry, If you're going to use an cooperative method, make it as 0. That's it. Simple. Okay. For using preemption, make is 1. For turning off the preemption, that is for using the cooperative method, make it 0. Okay. Similarly, you can give the CPU clock frequency over here. I'm just giving it as a system core clock frequency. Okay, like whatever the clock frequency the system core has, take it as a CPU frequency. Okay, and tick rate is I'm just giving it as an 1 kilohertz. Okay, and in last class I told you that priorities can be any number, but here we are using a priority for only 5, right? Okay, that is defined over here. You can give something like an 50 or 100, whatever it is. Okay, but the problem is the more the priority is given, the lesser your CPU speed will be. Okay, that is a problem. Okay, so you can give any numbers over here. For example, your application requires 10 priorities, then you can give 10 over here. Okay, and you can assign from something like a 0 to 9 frequency. I mean 0 to 9 priorities. Okay, so here I'm giving 5. So these are your stack size, heap size, and everything. Okay, so if you want to use a timer, make this as 1. Okay, and what is the maximum queue length? All these things are defined in this configuration page. Okay, you can just explore it. If you want to use something, make it 1. If you're not going to use it, make it 0. Simple. Okay, here I have made my preemption as 0. This first line. I'm saving this file. Okay, and now I'm closing this. I didn't made any changes in my code. I have made only that preemption as 0. Okay, now I'm building the code. Now I'm debugging it. Switch. Okay, and I'm just making this as a start trace and click resume. Now you can see only this task 2 is running. Okay, even though it has the same priority like 3 and 3. Initially both the tasks were running, right? Now you can see only this task number 2 will run because we turned off the preemption. That means now your scheduler has no power in switching between the task. Okay, now the user has all the control over switching between the tasks or context switching. Okay, we call that as a context switching here technically. Okay, so the context switching power as given to the user, or user has taken the context switching power from the scheduler. So even though if there is an high priority task available in the ready state, your scheduler will not take it. Okay, because we make it as a 0. Now how to use this cooperative method? There are some keywords or some APIs available. Okay, I didn't connect that. Okay, I'll just give it over here. So first one is you have an to type. Okay, I'll type this over here. Okay, so first one is your vtask delay. Okay, so this is one method of switching between tasks. Okay, if you give a vtask delay between two tasks, those two tasks will keep on switching because that is the only available task, right? If it is in the delay state, so it will keep on switching. And the next one is there is something called as a task yield. Okay, this is giving the delay time for the task. Okay, and this means task yield means I'm telling my scheduler that I have yielded. That means I have completed my job. Now you can give this task to any other, or you can use your CPU to any other task which is available. Okay, that is what this task yield means. Okay, I'm yielding my task. That means I have finished my job. you can now use some other task to execute. That's what I'm telling. Okay. So this is telling the scheduler to use some other task or to execute some other task. Since I have finished my current task. Okay. And sorry. So this is V task delay, this is task yield, and we have something called as an V task suspend. Okay, V task suspend we'll see in next class because we need to use an handler for that. Okay, we have V task suspend, then we have V task delete. Okay, and then we have V task set priority. Priority. Then anything else? Delay, yield, suspended, delete, set priority. Okay, that's it. So 1, 2, 3, 4, 5. Okay, so these are the APIs we can use in order to switch between one task to another task. Okay, so in cooperative method, we need to use any one of this API to switch between tasks because the switching will not happen by your scheduler. Okay, so we need to manually switch between the task. Okay, so first we will see one by one. First, I'm just going to give this. Today we will see these two things. Okay, we task delay and task yield. Okay, because all other things requires an handler. Hmm? Okay, so first I'm giving this V task delay. So I'm just giving V task delay of something like an 500 over here. Okay, and similarly here I'm just giving here I'm just giving 500. Okay, so I'm building the code and debug. My preemption is still 0 only. Okay, in the free RTOS config.htr file. Now I'm just clicking this data console and resuming. Now you can see on off is executing. Okay, so for every 500 milliseconds your task will be off and on, off and on, off and on. Okay, all these things will happen. Okay, so this is one way of switching between the task manually without your preemption or scheduler help. Okay, and there is one more thing you can give V or task yield. Yeah, so just give task yield. Here also just give task yield. Okay, it's need not to be always give for two both the task. Okay, if you want both this task has to be simultaneously executing like alternatively 1 2 1 2 1 2, then give in both the task, or you can give any one of this task as a task yield, other task will be keep on executing. Okay, so that is the thing. Task yield, you are simply telling this task has finished executing, execute the remaining task. That's what this task yield means. Okay, now I'm clicking this resume. You can see task 1, task 2, task 1, task 2, task 1, task 2, that is keep on executing. Right? So this is another way of switching between a multiple task without the preemption. Okay, so one is V task delay that we saw in our previous example itself, right? You can use that also, and there is something called as a task yield, right? So here you can see both are same priority. Okay. Now what I will do, I'm just going to comment this task yield. Okay, and I'll just run this one. Can anyone guess what will be the output?
I
I
guess
have
same.
commented. Mhm. Same
Same.
output. 1 2 will come.
Yeah, 1 2. Yeah.
Okay. I'll run this one. Okay. I don't know whether you can see this. I will copy and paste it in the notepad. You. Okay, this you have copied, right? Shall I delete this? Shall I delete?
Yes, sir.
Yeah. You can see my task number 2 has executed only once. Okay. After that, my task number 1 is continuously executing. Okay. Here also you can see task number 1 only. Okay. So what is happening is you are telling the CPU that this function 2 has finished executing. Okay, so that means it is executing only once and then it is yielded. That means this will never consider for executing the code. Okay, only this task will be available for your scheduler. So this task will be keep on executing. Okay, so that is what happens with the task yield. Once you give task yield, this will not be considered. Okay, if you give task yield in both the things, that means this task is yielded and we have this task, right? Now this task is also yielded. That means the other task which is available is only this. So it will just keep on switching between 1 to 1 to 1 to. If you give for only one, okay, that means this task is still not yielded, right? So it will keep on executing until you manually switch. Okay, if it is in preemption enabled, this will be 1 to 1 to as like how you defined. Okay, because it has an high priority or same priority, it will just keep on switching. But here we have given the preemption as 0. That means we have to manually switch. Okay, here we are manually switching it, but here we are not manually switching, right? So this will be keep on executing. So that is the difference between preemption and cooperative method. Cooperative method, user has to give the APIs to switch between multiple tasks. Okay, if user is not giving any APIs in any of the task will never switch. It will keep on executing for infinite amount of time. So that is the cooperative method. Okay, so in our RTOS, we won't mostly use cooperative method because if any high priority task comes, it has to address it first, right? So we will not mostly use the cooperative method in free RTOS unless your application demands it, or we'll be using mostly this preemption method only. Okay, so the same code, just give this task yield and check what is happening. That's it. Okay, is it clear what this cooperative method is?
Yes, sir.
Okay,
Yes.
yeah, copy this code. Finished, got output. Is finished.
No, sir. Sir, I'm getting errors, sir.
You're getting error. What is
Yeah.
error?
Can I share? Four errors are there. One is
Okay.
popular free RTOS portable.
Can you share the screen?
Yes.
Yeah. Okay. This is multiple definition. You need to go to this IOC and uncheck those three things. Open system core. NVIC. Yeah. Can I just drag this NVIC? Further. Just drag it to the top. Okay. Click this priority group and select 4-bit preemption. Okay. Go to code generation. Okay. Can you just scroll down? So remove the time base, appendable request, and scroll up. Yeah, system service call. Okay. Go to sys. Can you just drag it down? Okay. Time base source. Make it timer 3. Okay. Control S. Yes. Yes. Okay. Now build the code.
Yes.
Okay. Yeah. Have you copied and pasted that ITM code?
Oh, no.
That you need to do. Okay. Terminate this. Okay, copy that ITM code and paste it in syscall. Not there. Open src. Syscall.c. Yeah, you need to paste there. Where is the ITM code? Not there. You yesterday you have downloaded it, right? I have sent it in the group. This ITM Zencar.
Where I need to place it?
After that header file, scroll up. After that, yeah, line number 33, just paste it. Here you have to, in line number 108, instead of IoT put care,
Okay, sir.
Yeah.
So, I mean,
Okay. Yes.
okay, thank you.
Okay. So others, are you getting output?
Yes, sir.
Augustine, I didn't ask to you. Augustine Venkatesh, what happened? Okay. Okay. So this is what the cooperative method is. Okay, and we have few more APIs like priority set priority. Then we have an uh, suspend. Okay, task suspend, task delete. These are the some of the APIs we can able to use for this cooperative method. Okay, but for that we need to give this handler on the last parameter. Okay, so in next class we will see how to give a parameter and how to use an handler for the task creation. Okay, by using this handler we can control the task. Okay, that we will see in our next class. So your next class will be on Monday, as like I already said. I'm on leave on Friday. Okay, so we'll be having a class on 21st, and Saturday by 19th you will be having a C++ full module test. Okay, so I think you haven't written the C++ full module test, right? I think you didn't write. Did you? No. Yes, actually, this. Okay, Santosh took C++ for you, right?
Yes, sir.
Okay. Have you written the C++ full module test? No. I think I did some other batch, I think. Hmm. Have you written the C++ full module test?
No,
No, right? Okay.
no.
Then we will keep this full module test on 19th. Okay. I'll send the link on 19th. I'll give a 1 day time so you can either submit on 19th or 20th. Okay. So that is 3 hour test. So once you start test, the timer will start running from for 3 hours. Okay. You can either start it on 19th or you can start it on 20th. That is depends on your free time. But once you click start, then the timer will start running for 3 and it will be automatically submitted. Okay, so make sure you are opening it when you are free for 3 hours. So it will be an 100 marks test. You will be having 40 MCQs and 6 programming questions. So 40 plus each programming question 10 marks, 60. So you'll be having an 100 marks for C++. Okay. So once you finish that, I will send you the C++ project. And similarly, by next week, we will be having an pick project also. Okay. So I'll send the same thing in the group and in the message by today. Okay. And 19th, we will have a C++ full module test. Right.
Sir, autos will complete by next week.
Our task will take
It will go.
actually, we started on Tuesday, right? So one,
Yes,
two,
sir.
three classes, 4, 5, 6, 7, 8, 9, 8. Yeah, we'll complete before this August, I
Okay, sir.
hope. Okay, August
2 more
1st
weeks.
or something. Yeah, 2 more weeks we require.
After that, we have um,
We have IoT.
IO.
Yeah. Okay, AWS IoT. We will see that one. Okay, for that we required
Okay.
ESP32 as well as Raspberry Pi.
Yeah, Raspberry Pi only.
No, we
I don't
can.
have that model. Yeah, other
You
two
don't
I have.
have ESP.
The ESP I have. Yes.
ESP, you don't have a Raspberry Pi.
Yeah, RPI I don't have.
Okay, RPA, you don't have.
I'll buy it.
Okay, 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 okay.
It's quite costly, 10K actually.
Yeah.
That's with the case.
with case and cable
Yeah.
and memory card. All these things will come in a package.
It's a Kale software only will use it.
For
Kale
which one?
OS. RP.
No, for Raspbian OS we will use.
Okay, different. Okay.
Yeah. Okay. So
Sir, we cannot use simulator.
no, the thing is you will be actually sending a data to AWS cloud. So AWS IoT will provide an authenticated certificate for the data transfer. Okay, you need to put that certificate in a device. That will not be done in the simulator. Okay. Yeah, you can use some simple the sensor data collection and all these things that can be done in simulator, but when you have to transfer the data to the cloud, you require a board. Okay. You can use an ESP32 also, but with Raspberry Pi you can easily able to transfer the data.
This board we cannot use. No?
We will see two different things. One is with ESP board, we will transfer a data to ThinkSpeak. Okay, that is a math work based cloud provider. And with Raspberry Pi, we will transfer the data to AWS IoT core.
Okay.
Okay.
Raspberry Pi have inbuilt Wi-Fi module, I guess.
Yes, it has an inbuilt Wi-Fi. And ESP32 also having an inbuilt Wi-Fi.
That is not required for RPI, I guess. It's for STM32.
Which one?
I mean,
ESP.
ESP32.
ESP32 is an Atmega.
Oh, for the Arduino board. Okay.
Yeah, same family. It will come.
We can configure with that STM32 in a UART mode with STM32.
Yeah, we can configure that one.
Okay.
We will see. We will explore about. Okay, we'll see how to do this. But for AWS IoT, anyhow, you'll be requiring Raspberry Pi. Okay, we will see that, and we can use that same thing for the Edge AI also. The same Raspberry Pi.
That is latest current. Yeah.
Yes. Okay. So it will be anyhow will be useful for you. Okay, we'll see that after this module.
Oh, sure.
Yeah.
Sure.
Okay. So, and thank you, and prepare for that test on Saturday. Right. Okay. Thank you. Bye.
Bye, sir.
Bye. Thank you.
Bye.
Bye.
Thank you, sir.
Thank you. Bye. சொல்லுங்க நவீன்.
சார் அது செக் பண்ணலாமா சார்? அது ஏன்
இந்த செகண்ட் ப்ரோக்ராமும் வரலையா? அதே மாதிரி மெத்தட் ட்ரை பண்ணி பார்த்தோம்.
நான் ட்ரை பண்ணி பார்க்கல சார். ஏன்னா அது நடுவில் எனக்கு நிறைய ஸ்கிரிப்ட் அது மறந்து போயிடுச்சு. ஸ்டெப் என்னென்ன பண்ணணும் சொல்லிட்டு. ஓகே. ஐ திங்க் நடுவில் எங்கேயாச்சும் ஒரு ஸ்டெப் விட்டுருப்பீங்கன்னு நினைக்கிறேன். அதனால தான் வரல. ஏன்னா போர்ட் கனெக்ஷன்ஸ் எல்லாமே ப்ராப்பராக தான் இருக்கு. இந்த ரெக்கார்டிங் பார்த்து ஒரே ஒரு டைம் மட்டும் ஃபர்ஸ்ட்லேருந்து ப்ராப்பராக செஞ்சு பாருங்க. அப்படியே அவுட்புட் வரல அப்படின்னா எனக்கு மெசேஜ் பண்ணுங்க. I'll tell you what to do. ஓகே. நம்ம ஒரு ஸ்டெப்பா டீபக் பண்ணி பார்க்கலாம். ஓகே. ஓகே. சரி. ஓகே. சார் ரெக்கார்டிங்ஸ் அப்லோட் பண்ண மாட்டேங்கிறாங்க. அது கொஞ்சம் லேட்டா நான் தான் பண்ணணும். நான் பண்ணிடுறேன். ஓகே சார். நீங்க டே பை டே பண்ணீங்கன்னா அது கரெக்ட்டா டிவைஸ் டிரைவர் வரைக்கும் ஃபுல்லாவே போட்டாச்சு. ஓகே. RTOS மட்டும் தான் நான் இன்னும் போடல. இன்னைக்கு போட்டுறேன். டிவைஸ் டிரைவர் வரைக்கும் ஃபுல்லாவே போட்டுட்டேன் அதுல. ஓகே சார். நீங்க எனக்கு போட்டுட்டீங்கன்னா நாளைக்கு கிளாஸ் உள்ள நான் கொஞ்சம் ட்ரை பண்ணி பார்ப்பேன். சரி ஓகே. நான் இன்னைக்கு போட்டுறேன். ஓகே. ஓகேமா. ஓகே சார். தேங்க் யூ சார். தேங்க் யூ. பை.